All right, before we jump into the product, I want to spend a few minutes just on the concept itself. So this is an ensemble definition. It's essentially a saved recipe on your app that runs many configurations at once and returns the best result per request. So most real decision problems have more than one reasonable configuration. A solver weight that works on one input isn't always ideal on another. And whether it's routing, allocation, or another use case, the pattern is the same. So there's a set of knobs. Each setting is a reasonable trade-off. And retuning it by hand every time just doesn't scale. So the idea here is to let the platform try them all and keep the winner based on a set of rules. So let's define what we mean here in more detail. So an ensemble definition bundles two things, a set of run groups. So these are different configurations of your app, and a set of rules that decide once those configurations have produced their results, which one gets returned. So you have one input in, and candidates produced, and one winner out. So run groups are the configurations. Each one points at an instance of your app and can override any of its options. You might have one group with a tight MIP gap and a loose one, as the more solver focused example, one with a balanced batching strategy, one with a clustered one. But in every case, it's same input, different settings, many candidate solutions, all running in parallel, and then one ultimately returned. So the rules decide who wins. They're applied in order, top to bottom. If two runs tie within a rule's tolerance, the next rule breaks the tie. This is called lexicographic selection. And it matters because we're not collapsing four priorities into a weighted score that could potentially surprise us. So in this case, feasibility strictly beats service, service strictly beats fairness, and so on. So the clearest way to see this is with a worked example. So let's just start with a simple example. So in this case, we have 4 candidate runs, 4 different rules. Each column is a rules metric, and we can kind of look at how the field narrows as we go through each rule set. So rule 1 is feasibility with a tolerance of 0, and run C has a violation. So it's eliminated immediately in this case. No downstream rule can save it. So now we move on to rule 2. Rule 2 is service quality. Tolerance is 0.5%. So in this case, A, B, and D are all within that tolerance of each other. So none of them wins or loses here. So we keep all of them and move on to rule 3. And rule 3 is fairness. So run D has the best value here, well within tolerance of the runner-up. So D is the winner, and that's the result the ensemble would return in this case. So now, how do you set one of these things up in the console? So there are 5 steps in the Nextmv console for setting up an ensemble definition. So first, open ensemble definitions under the More menu in your app, and we'll see this in the console shortly. You create a new one, name it, give it an ID, add your run groups, add your rules, and that's really it. You save it and you're good to go. There's no code, no other kind of SDK, API calls, whatever required. You can do it all through console if you want to. You can also do programmatically if you prefer, and that is a nice way to scale it down the line. So when is it a good time to use an ensemble definition? So there are 3 common patterns that we see where this really pays off. The first is parameter sweeps, when you're exploring like tuning different knob values, parameter values. De-risking deployments is another use case when you'd rather ship several candidates and then commit to one. And multi-objective trade-offs is the other one we see when your priorities don't collapse cleanly into a single score. So that's kind of the end of our overview. The kind of TLDR is with an ensemble, you define it once, you can run it any time, and you always ship the winner. So that's the conceptual picture. And now let's dive into the real thing in your workspace.